Hi and welcome to the first class of Python in Cinema 4D. My name is Michael, and together we're going to have a look at how to use the Python language to create art, to improve our pipeline, and to extend the capabilities of Cinema 4D. Now I know that programming is usually a bit of a dry subject, so I'm going to try and teach it through practical examples right from the start as far as possible. However, before we jump right in, we should probably sort out our desktop and make sure that our layout of Cinema 4D is up to the task. And for that, let's have a look at the layout as I have set it up here in my Cinema. So what I usually do is I customize my toolbar first of all, because there's a couple of things that I always use, like the null object and these four icons here. So I always have them here. So let's do that first and customize our palette. And the shortcuts you're really going to look for are first of all the console. You really need that, so that's in there. Then there's the script log, which you will also find in here. There it is. Then there's the reload Python plugins. There we go. And to add them, you just grab them and drop them onto the toolbar wherever you want. So, and then there's a final one, which is the projects one, which you don't necessarily need, but I find it really useful to have. So that's just called projects. And what that does is it's just a drop down that shows you all open projects. So if I had a couple of them open here, you would just see them in here. It's really quick to switch between projects that way. Okay, so these are the shortcuts that you should add to the toolbar. And then, of course, you should probably have the console sitting somewhere in your layout. Either add it here to the side, that's always quite useful, or because I am kind of limited in space due to the recording here, I have added it here next to the script manager. But you can add it wherever you want. It's just you should really have it visible while you're programming, because that's where you're going to see your console output. All right, and that's basically all you need to set up, really. Another thing you may want to do, especially if you're working on a larger monitor, or if you're doing screen recording like this, you probably want to increase the font size here, because that's normally quite small. You can do that in the preferences. In the interface section, under the monospaced font, you have to unfold it here, and then you can set up whatever you want. Now I've chosen 16, it's just so you can read it better in the recording. Normally you would probably go with something like 12 or 14 or so. Okay, and that's really all you need to do, and that should give you a proper setup to get started. All right. Oh yeah, another thing I wanted to mention is, right from the start, is get a decent editor. I mean, the built-in editors in Cinema are nice. They do have syntax highlighting and everything nowadays. But they're really nothing you want to program in once you get over a couple of dozen lines of code. The main reason being that for some reason, all the editors in Cinema do not support undo. So Control-Z won't do anything. So that's why you should really get a decent editor and then just copy and paste your code in there. Personally, I'm using an editor, and you're gonna see it really often in the next couple classes. It's an editor called Sublime Text 2, which I can really recommend. It's available for free. It's shareware, so you can use it as long as you like, as far as I know, and it's really cheap as well. But the best thing about it is not only it has great Python integration, but also it's multi-platform, because I'm always developing on Windows and OS X at the same time. So it's great to have the same editor, the same shortcuts and everything available on both systems with the same color syntax and all that. So yeah, highly recommend it. But of course, any editor will do, really. Yeah, and then do your development in here, and once you're done, just copy and paste it over into Cinema. Or actually, with some of the editors, they actually auto-update, but we'll show you more about that later. So now that this is all set up, I think we should have a quick look at all the places where Python is now supported in Cinema 4D. So let's get rid of this for now. And let's have a look at the basics. So let's just create a box and create the first tag, which would be the Python tag. It's under the scripting tags, Python. And there we have it. There's our Python tag, there's the Python code, and that's going to affect the object that's underneath. So that's the first thing. Then we have the Python generator, which is under the script menu. There, and again the code is here, and that is going to create geometry by itself, so it's not using, or not necessarily using any other object, but it can. So that's the second one. Then we have the Python expressor node. Let's just create a null and create an expressor script. Let's drag this in here, and then there's new node, expressor script, and there's another one. And let me just drag this here. And again, when you click on it, you can see the code here. And then open. Let's get this back in. So then when you click here, that code in here is going to open in the expression editor. Okay. Let's make some space again. Close this. Right, the next thing is we've got the MoGraph Python effector. So that's going to be in the effectors, and where is it? There it is. Again, code is in here. It has two modes. I won't tell you too much about them now, but we will have a separate class just about this one. It's really powerful, something to look forward to. And then, of course, we have the editor itself, the one I've already shown you, especially this one here, where you can run your own scripts, regardless of any objects in your scene, and just execute them. And then, of course, last but not least, there are plugins like these here. These are just a couple of examples, but you have these kind of plugins which are command plugins. Then you can create your own tags, you can create shaders, you can what else? You can create your own objects based on Python plugin. There's plenty of stuff there. And again, we're going to have a couple of classes just dedicated to plugins. Anyway, now that we had a quick look, I think we should also look at some resources where you will be able to find documentation and help about the Python API of Cinema and Python itself. Just to look up the syntax and the available functions when you want to try out stuff yourself. So this is all web-based, so let's have a look at some links. The first thing you should definitely do is go to the Maxon homepage. Now this link that you see here, this one here, you don't have to remember that one actually. What you have to remember is Plugin Cafe. So if you go to plugincafe.com, that's going to forward you to this page. Now Plugin Cafe is Maxon's developer site. So on the one hand, you will find the SDK documentation here, which is something you will definitely need. And you will also find the developer forums here, which are really useful when you just have questions about C++ programming, Python programming, Coffee, or anything Cinema development related. So it's not a general Cinema support forum, it's really meant for developers. What you will also get here is plugin IDs. We're going to have a look at those later on, but just so you know, when you need a plugin ID, this is where you get them. So the first thing you should definitely do right off the bat is download this one, and this help here. So these three. Definitely these two. The Coffee one is definitely a plus to have. So the Python one, of course, you should know why we need that one. The C++ one we need because the Python documentation at times is a bit inaccurate. Some stuff is missing and some, I don't know, it's maybe copy and paste errors, but there are a couple errors in the Python SDK that you really need to look up in the C++ SDK to get it working. So these two are must. Download those immediately. I already did that here, so this would be the C++ API documentation. And yeah, well, it's quite straightforward really. Lots of stuff in here. probably want to use the index quite often. And then we have the Python documentation. Again, lots of stuff that we will go into later. The coffee one, well, let me just quickly open it. Looks like the C++ one. You will probably never use this one, but it's good to have it just in case. Another great site to look at is Stack Overflow, which is just brilliant when it comes to programming in general. Not just Python, any programming related stuff. Any question you have, there's a good chance that it has already been answered in here, or if not, you can ask questions and really competent people will answer. So that's definitely a page to know. And then of course there's the Python documentation itself. I have linked two of them here. There's the current one, the current version 2 branch one. That's the 2.7 one. And then I also have the 2.6.8 one linked here. Notice the difference up here. When you go to the current one, you just have to type in docs.python.org, which in most cases is fine, but there can be slight differences between versions. And in those cases, you can just add release and the version number in the back. And then you end up with the documentation for, well, that version. Now, I've jumped ahead a bit because I gave away that we are looking at version 2.6. Actually, not 2.6.8, but another version. So the first thing we do in Python at Cinema now is to find out what version of Python we're actually going to use. So let's close Firefox and let's actually hide this as well. And no, actually, sorry, it was a bit quick. What we're going to use is the console now. The console is a really great tool because not only is it going to give you error messages and console output, it's also a Python shell. So when you have to select Python down here, not coffee. You can switch between coffee and Python mode. You can see the editor changing as well. So we want Python mode. That's important. And then you can run Python commands straight from this command line here, and you will get the output up here. So to find out what version you're actually looking at, and this may be useful if you are switching between versions of Cinema, like release 12, for example, because they were using different versions of Python. So what you do is you import the sys module, and you can see it's okay, no error, and then you just type sys.version, and there we go. So that's telling us, well, this is the long part, but what we are looking for is just this part here, version 2.6.4. So now we know. This version is the same as the version of Cinema that you're using. So if you started the 32-bit version of your Cinema, you would see the 32-bit version of Python in here. And actually, now that we're talking about it, it's probably a good time to also look at where the Python files are actually located. Because normally you would have, or many of you probably have a Python version already installed on your system. And that's somewhere like C Python 2.7 or whatever. But that's not the one that Cinema is actually looking at. Cinema comes with its own Python interpreter. And that's why whatever you do in your systems, in your operating systems Python, doesn't affect whatever's happening in Cinema, because let's open the Cinema folder here. Obviously I'm working on Windows, but the file structure within the Cinema folder is exactly the same on Windows and on Mac. So on Mac you go to Applications, Maxon, Cinema 4D, R13 or R12, and once you're in there, it's looking exactly the same. Right, so what we're looking at is modules. Whoops, sorry. See, it's actually quite confusing because there are a number of folders that are looking the same, that have the same name. So what we're looking at is not modules, but resource and then modules. And then in there you will get the Python module, and then again resource, and now we see the actual Python framework. And within the framework you will have the Python interpreter. Now what are these? So we have the 64-bit version, we have a 32-bit version, and we also have the Mac version in here. Now to be honest, I don't know why the Mac version is in there on the Windows version, but on the Mac version of Cinema you will also have both Windows frameworks. So it's basically, once you're in here, the entire application folder of Cinema 4D looks the same on every system. Right, so the one we're working on just now is the 64-bit version. So let's have a quick look in there. A very interesting folder in here later on will be the lib folder, because in there we have a subfolder called site packages, and it's empty at the moment. But if later on we want to use external modules, there are a couple of popular ones, then we would have to drop them in here. And for those, again, it's important to know that we are working with version 2.6.4, because many of them are compiled and require a specific version of Python. But we don't need that right now. It's just so you know already, these are the important locations. Okie-doke. So what have we done now? We have set up our environment. We know where to find documentation, and we know where Python is, and we know which version we're working on. I would say it's time to actually do something with it. And for that, we will clean out this scene here, and we will just create a cube again. So let's clean this as well. We have a cube, and there's really nothing special about it at all. And let's add a Python tag. And let's have a quick look at what's in here. So this is the code that's in the tag, and to edit it, you can edit it straight in here, but you really do not want that, because for one, there's no syntax highlighting, and you also can't see spaces too well because it's not a monospaced font. And especially with Python, where the indentation is really important, you do not want to edit in here unless it's really just a typo. So always click on the editor, and that will open that code within the expression editor. And which, by the way, if this were closed and you clicked here, it would open automatically. So no worries there. And then we just open our console again. And again, I'll drag that next to it. Right, so we're back. Okay, so this is our code now. This will always be in there. Let's have a quick look what this does. Absolutely nothing. So what does it do? First of all, we are importing the c4d module. Now the c4d module is the core module of Cinema4D's Python implementation, and that's what's containing most of the functionality you will use. There are a couple of submodules that are within c4d that you will also use, but right now c4d is the most important one, and every script you will write within Cinema in Python will use this line here. That's always there. This comment here, well, we don't really need that, but let's leave it in there for now. And with the Python tag, the Python tag itself, when it's running, it will always automatically call the main function. So you don't have to put anything here. You don't have to actually call the main function. That's automatically being done by the tag itself. And then what it does is nothing. As you probably know, parse in Python is just a placeholder, because you can't have, actually let me just show you, because you can't have something like this. So this is a function definition that does nothing, just empty underneath. And if I press on compile, difference being here, execute would actually run the script, compile just compiles it and checks for errors. And there we go, there's a syntax error on line 6, which would be here. And the syntax error is that there is nothing. So you can't have nothing in after a colon. So again, parse, and no errors. So parse does nothing. That's not enough. Let's actually try what we tried on the console straight from the tag. Why not? Let's import sys and call sys.version. Actually, let's print this.version. Let's see what happens. No error. Execute it. There we go. We get the output that we wanted. Which also shows you that the tag doesn't necessarily have to do anything with the object. You can run any kind of script from anywhere. It's just another Python script. But of course, if we put a tag on an object, we want to do something with the object. So let's throw this out again. And let's try to access that object there. So for this, Cinema gives us two predefined variables. there's one called doc, and there's another one called op. The op is the object that the Python tag or the Python script is running on, not just a tag. So in our case, the Python script is running within here on that Python tag. So let's see what happens if we say op and get name. Now get name is a function from that the operator or the op object gives us, and let's see, it will tell us Python which is the name of that tag here. So let's call this my tag instead, just to show you. There you already see. And something else you already saw, these tags, they will auto update. So every time on every frame it will be called once. So you see, this is nice if you want to animate something based on the timeline and you want to call the script every single time. Alright, so here we get the name. But what we want to access is not the tag itself, what we want to access is the object. So for that there's another function called getObject. So let's see what that does. Now you can see here that returns a base object called cube. That would be this one here. Base object is the, well, as it says, it's the basic class of all objects within Cinema 4D. So any of these objects here, they are all based on base object, and then they all inherit base object and then become something else later on, like a polygon object or a point object. But deep down they're all base objects. So now we have a base object. We can again say get name, and there we go, we get the name of that object. So now we know this will be the object that we're playing with. So let's get rid of this and let's write this into a variable. So our object will be the parent object of that tag, this one here. So from now on we will work with this object. So what can we do with this object? Let's see. Let's have a look at the object. This is a cube and it has, well, 3 sides. Well, there's more sides, but it has 3 lengths and segments. Now we want to change the number of segments, and we also want to change the size, let's say. So how would you find out what the name of these variables are? It's actually really easy. Let's clear this. All you need to do is you can just drag it and drop it in here. Let's make this bigger again. And then you see here this cube, and well, then let's see the key value. Basically, to access variables of an object, you use the dictionary syntax of Python. So let's actually try this out on this example here. We have our object. Again, we use print so we see something. Object, and then I just copied and pasted it in here. So let's see. We have our object, and then we look into the object, into the parameter that's called primCubeLength, which is the primary cube length. And some of these have a second parameter, like this one here. Again, it's all in what you see here. So that tells us we want to get the cube length, and we want to get the x length of this. And if I press execute now, it tells us, well, it's 200. And the same way, we can actually change it. So instead of just printing it, we can actually tell it to be 100. And there we go, now it's 100. And you see it update here as well. So it's this easy, really. And there are also a bit simpler ones like this one here. Now this one, you see, is only one parameter. And again, we can tell it obj 5. And there we go. Now our cube has 5 segments. And this works for really most of these parameters here. You can even tell it to be filleted. So let's say again. Now, this is not a numeric value, this is a checkbox. So checkboxes are represented as Boolean values, so either true or false, checked or unchecked. So currently it's unchecked, so it's false. Let's make it checked, so call it true. Note that in Python you actually have to capitalize the first letter here. So true starts with a capital T and false with a capital F. Unlike in C++ or other languages where it actually has to be lowercase. So it's true and it's false. So in our case we want it to be true. Execute it. And you see, now we have it filleted. Okay, and if we scrub through here, nothing really happens. Because these are all fixed values and every single time this is being called, it's just setting the same value, which is quite boring actually. So why don't we animate this using the timeline? And for this, we obviously need to know which frame we're at, or at which point in time we currently are. So for this, there's a second object that's already preset by Cinema. So we have the op object, like I said, for the object that the Python script is running on, and we have the doc object, which stands for the document that is currently open. So again, let's have a look what it says. Print doc, execute. There you see, it's a base document, which is every document, and it has no name, and yeah, but it's there. So what do we get from the document? Well, we can have a look at the time. So let's say get time, and let's see what it returns. Well, it returns an object called base time. Cinema is storing the time not as frames and not as seconds, but as fractions of the current frame to the frames per second. So let's say our document has 25 frames per second, and we're at frame 12. This time would be stored as 12 divided by 25. Now, this is not really convenient to handle for you. So what we do is we get the time, and then we use a couple of functions that will in the end give us the current frame, which we can then use to, well, do whatever with. So how do we get there? So now I already know that doc will return a base document. And I already told you that get time will get me the base time. But how do we get there, even to this point? Well, we look at the Python documentation, of course. So let's have a quick glance at that. So I showed you this before. This is the documentation. And well, let's start with the Cinema 4D module, the base one. And we can already see there's the base time that will get returned from the document. But we don't see the document in here. That's because the document has its own section here in c4d documents. So here we have the base document. Now you can see there are some functions that belong straight to the module, but the one we are looking at is the base document class and then its function, so its methods. Now there are a whole lot in here, but we already know we're looking at the get time one. So let's see what that says. Well, it returns the time as a base time object. Alright, so let's click here and see what the base time object actually gives us. Ah, this looks good. There's a get frame function, so let's see what that does. It will return the current frame based on the current frame rate. Like I told you, the time is stored as a fraction of the current frame rate, so we need to give it the, or any frame rate, not just the current one. So we need to give it a frame rate so it can reverse calculate the current frame. Well, we already know that our frame rate in our case was 25, but what if you want to write a script that can be run in any situation? So you want to know the current frame rate based on the current document without having to type it in manually. So unfortunately there's no function here to find out the frame rate. But there's one within the base document. So let's go back and scroll back up to the list here, and let's go through it from the top. And at some point, yes, this one looks good. So there's get FPS. Let's go there, and that one needs no parameter or anything. It just returns an integer of the current frames per second. So that's perfect. That's exactly what we're looking for. All right, let's try this out. So we're already getting the time. And I hope you're familiar, at least a bit familiar with Python. So we can, if we now put a dot in here, that means we are going to work on whatever is being returned here. So we could either do this, base time equals this. So base time would now be our base time object. And then we could say, so like this, FPS is like doc.get FPS, and that would return the FPS in here. Let's actually see that this works. So base time print FPS, and let's get rid of all of this stuff here for now. Compile, no errors, and there we go. So, oh sorry, I was lying actually. The document is currently set to 30 frames and not 25. Let's see if this is correct, but I'm pretty sure it is. There we go. So project settings, 30 frames, and that's what Python telling us as well. So that's good. All right. So, but we wanted to get the current frame. So now we have the base object and base time object, and we have got the FPS. So now we can use, we can use it just right in here. But get frame. And FPS. That's this one here. And let's see what happens. There we go. It's frame 12 now. So, but this is a bit inelegant because we're using variables that we don't really need. So what you can also do is, so let's keep this here as it is. Let's get rid of this as well. And let's make this a bit more, bit nicer. Frame plus. Right, actually something else I want to show you. This looks quite good, doesn't it? So this should concatenate these two and then give us a nice string, current frame 12. Let's see what it does. Oops, there's an error. That's because you can't add a string to the an integer to the string right just like that. But it's really easy. Just always remember to put something like this around the integer. So the str function is going to make whatever's in there a string. So now this is going to work. Perfect. So instead of this up here, you could just as well just write and then it's doc.getTime dot get frame doc get FPS. Oops, we're leaving the screen here. Okay, so I suppose what do I do? Whoops, I forgot the brackets. Oh, see, I fell in my own trap. So again, the string. Okay, but now it should work. There we go, now it works. So I leave it to you which one you want to use. I mean, this is probably easier in the beginning. Just put everything into separate variables so you can really sort out what's going on. Later on, you're probably going to use these methods here. Just put it all in one line, and well, you're only calling it once usually within the your script anyway. Because once you have the current frame, you don't have to do it all over again. And that's actually what we're going to do now. We're going to put this into a variable. So current frame equals, well, we don't need a string for this, so this is it. And this one we're going to just comment out for now. So the comments are always these hashtags. Right, so now we have the current frame. So what can we do with it? We already know that we are able to change the size of our object and any of the other parameters through Python. And what we really want to do, of course, is to move it around and to rotate it automatically based on the script. So for that, we have a couple of functions that are part of every base object. And let's have a look at those. So it's in the c4d module, and you scroll down a bit, and here are the different object types. So the base object is what all the objects are at their root. And then you have some more specialized objects later on. But generally, what we're using to set the position and rotation and all the basic properties of an object is all located within the base object. So click on it, and let's have a look at all the functions that this offers. Now we have a couple of functions to set the position, the rotation, and the scale. The absolute positions, or generally the set absolute position, scale, and rotation functions are going to set the position, scale, and rotation in world space. The relative ones are setting the position, rotation, and scale relative to the object's parent. So if your object is sitting in a null object, this is going to be the position relative to that null object. The frozen position is a bit special. Let's have a quick look here in Cinema. If you look at an object, you can see here the coordinates, and you see here the freeze transformation. And the freeze transformation is, let me just demonstrate it. I move it here. Now currently, let's make an even number, we're at x at 200 centimeters. Now if I were to freeze the position, we are at a relative position of 0 again, but the frozen position is 200. And the world position is 200 as well. So here you can already see quite nicely what these functions do. So one will set the world position, one will set the relative position, and one will set the frozen position. Now let's unfreeze this and go back to 0 and go back to our documentation. There it is. Right, there's lots more functions available here, like functions to get and set the matrix of your object, which is a bit more advanced, and we will look at that later in a later class. Let's stick to the position rotation now. For now, let's see what this looks like. So the get and set position. Get will return a vector, and set will expect a vector. Now, a vector is, in programming terms, a vector is just a collection of 3 values, x, y, and z. So these are going to be floating point values. Let's click on this and have a look. You can see it here. If you initialize a vector, it requires at least one number, which is x, but usually you would give it x, y, and z as floating point numbers, and then you have your vector. You can see here there are a couple of convenience functions, like getting the dot product or normalizing your vector, which is very useful in all kinds of calculations. We don't need it now, but keep in mind they are available. This is also quite interesting, returning it as a string. You don't really have to call these functions, these ones with the 2 underlines. They are, Python is usually good at recognizing these functions out of within its context. So if I were to just print a vector, it automatically calls the string functions, converts the vector to a string, and you get this nice human readable format as on your output side. Again, something to remember. But for now, we are going to create our vector and feed it into a set position, and then back into our object. So let's have a quick look how this works. Here we have our Python tag again. I cleaned this up, so now we're back to the basics, which is nothing at all. Right, so let's go from scratch again. First of all, we get our parent object, the cube object here. So if you remember correctly, the OP object was already preset with the Python object itself, which is our tag. So this would be the tag, and we want to get the object that this tag belongs to, which is cube. Then we want to get the current time. So the current time, oops, is based on our currently open document, which is doc. Again, that's preset by Cinema for you. And it's get time, which will return an object of base time. And then that base time again has a function called get frame, and that expects the currently used frames per second. So we get that again from the object itself, get FPS, and this is a function. So it's a function that doesn't require any parameter, so it just returns an integer of your frames per second. We close that. Now this is going to feed into get frame, and that's going to return the current frame. And of course we're not at current time, we want to call this current frame. Actually, to make it a bit shorter, we just call it CF. But just put a note in here that means current frame. I'm just using CF because it's just much less typing and we don't have that much space here, so we end up with lines that extend over the edge of the screen. So usually it's a good idea to give your object or your parameters, your variables, better names. Right, so these frames of course increase by 1 every frame, and for our movement or for many things like rotation, this can be too much, especially with rotation, because rotation in Cinema and in most 3D applications actually internally doesn't work with degrees. So while we usually work with degrees from 0 to 360 or 359, programs internally use radians instead. Radians map 1-to-1 to degrees, but where degrees go from 0 to 359, radians go from 0 to 2 times pi. And to get the radian from a degree, or from any number really, you use a utility function that Cinema offers you in its utility module. So let's look at this as well. So you've got c4d utils, and in there you have a number of really useful functions. Again, this red. So that's the one we're looking for, red and deck. Right. So let's import c4d utils. Or actually, to make it even easier, use this from c4d utils import everything. What this does is it saves us some time typing c4d utils every time. So you could call that function this way, or because we have now imported c4d utils and all its functions within, you can just type red 1, 2, 3. Same thing now. If you didn't do this here, this would cause an error and this would work. But we did this, so let's get rid of this. And we're going to feed it our current frame. And we are going to make this our radian current frame. So it's RCF. Alright. So now we have a relatively large number and a relatively small number. And because we want to have some movement that doesn't just go into the horizon and just leaves the screen, we want it to oscillate instead. So for that, well, the best thing to use is always sine and cosine, because they will always go from -1 to 1. Again, we have that function in c4d utils, and it's called sin cos. So you don't have a single function to get sine and cos, you have one function that will return both. So we feed it the radian. And because this will return both, it returns a list of 2 values. So what we do is we call it one sin and one cos, and this is going to fill both of those. So this will contain the sine and this will contain the cosine. All right. Okay, so now we have some values that are going to change over time. What can we do with this? Now we were planning to move the object around. And one way to move something around was to change these fields by dragging this in. Actually, I didn't show you before. You don't have to drag it into the small field here. You can actually drag it right into the source code, which is of course much easier than copy and pasting it from there. So we just have to put obj in front. And now we could change the position x, or actually if we wanted to, we could change the entire position by feeding a vector in it. So the vector is being called by c4d vector, so that's creating a new object of type vector, and it expects 3 values. Now let's just put in the current frame, and the current frame, and the current frame. So that's going to be x, y, and the all being the same value of the current frame. Compile, no errors, execute, nothing happens because we're currently at frame 0, so that's going to return 0. So let's see what happens if we press play, and it's slowly moving away. Right, so that's working, and you can see the values here increasing with the frame counter here. So, but that's still a bit boring. But before we make it a bit more interesting, I would actually want to show you a second way to set this vector. So what we did now was we were setting it by dragging this in here and setting the dictionary object. But instead you could also use that function that we looked at before, set rel pos, which again expects a vector. So we take the same vector here and put that in here, comment this out, and if all goes well, what happened? Okay, well, it's okay now. So if all goes well, this should do exactly the same, and it does. So again, look at this. So these two are doing exactly the same. They're just two different ways to set the position of an object. So just keep that in mind. Actually, for now, because it's shorter, we will stick to this one. So this one goes away. So let's set the rotation as well, and it's exactly the same process. Set rel rot, and let's copy that in here, and let's see what happens. Compile it, execute it. Whoa, that's way too much rotation. So this is what I was talking about earlier. The rotation is expecting radians, or is rotating by radians. So if I feed it the current frame, this goes way over 2 times pi. So every 6 or 7 frames we get a complete rotation. We don't want that. So that's why we use the radian in here. So let's use this one. Again, compile it, execute it, and play it. Much nicer. Alright. So this works nicely, but it's a bit inflexible, because if you want to change something, you have to go into the source and you have to, well, change the source code, compile it, execute it, and then you can check your changes. We don't want that. What we want is a nice user interface. Luckily, it's really easy to create your own user interface within Cinema by using the user data functions. So just click on user data and select manage user data. You could just add user data and it would add one for you, but we want to add several. So we open the manage user data dialog. And in there, we're going to add 2 of them because we want to modify the rotation and we want to also modify the movement, the position in space. And actually, now that I think of it, let's add a 3rd one, because maybe we want to put some randomization in there. So let's look at the first one. The first one is supposed to modify our rotation. So we call that multiplier rotation. And that's going to be a floating point value. Sorry, it's going to be a slider. So here you see a preview here. It's not going to be %, it's going to be a real. And we want it to go from 0 to Oh, I don't know, 50 is probably enough. And we don't want to go, we want to set the stepping size to 0.01. So you see now we can change the value like this, and we make it default value of 1. Okay, so we do the same thing now for the position, so we call it multiplier position. Again, float slider, real. Let's make this 200. Again, default value of 1, and this 0.1. Alright, and this we just call random. And this is not going to be a floating point number, because what we will do is we will change the random seed value. The random seed value is used by the randomization function to create pseudo random numbers. So numbers are never really random in programming languages, so they're all based on some seed. This has the disadvantage that basically, like I said, you never get a random number, but it has the big advantage that you can actually predict your random number. So if the seed is the same, your random number is always going to be the same as well. Which is great for things like if you were to set something to a render farm, you don't want your scripts to result in different random numbers on every machine, because then you get flickering and stuff moving all over the place. You want it to be the same random number everywhere, and then you get that by using a fixed seed. So we're going to call this random seed, and it's going to be an integer because that's what it expects. Step 1 is fine. Limit is going to be, I don't know, 100,000. And let's do this at 10. Doesn't really matter. It can be any number. And we make it the default number 1, 2, 3. 1, 2, 3, 4, 5. There we go. Okay. And now if we click on the new user data tab here, we have our values. And it's really easy to get to them, just like with every other field in here. You just drag it in here, and there you have it. So you see it's ID, user data, and a number. And the number actually is this number. This number here, that ID. So it's 1, 2, and 3. So that's how we get to these. So again, to make it a bit more readable, let's create some... Oh no, let's do that on top. So we get our multi, what? That's for the rotation. And we do another one for the position. That's number 2. Oops. And we have our seed. That's number 3. 3. Okay, so first of all, let's multiply our rotation. So we got our radian, and we are going to multiply not the radian itself, but the current frame that's in there with the multiplier. You could of course multiply that as well, but with these numbers that would get too big too quickly, so you just multiply the current frame. And now we do the same thing, not to this value here, but we multiply the position here. So we've got the multipos. And let's see. Right. Now actually, to get some more interesting movement and not just a linear movement, let's use the sine and cosine values that we had before. So let's set x to sine times the multiplier. Let's set the y to cosine times the multiplier, and let's set z to again sine times the multiplier, and let's make that, oh, I don't know, a bit more interesting, times 2. Okay, let's see what happens. Compile it, no error, execute, and we did get an error. Let's see. So in line 12 it says a float is required. Now where's line 12? Here. You see, we are multiplying. Oh yeah, Radiant is expecting a floating point number, and what we're getting out of here is not a float. So we can easily fix it by making it a float. So either one should do. Let's make this a float just by putting float in front and then putting it in brackets. So that's casting that variable to a floating point number. So this should hopefully now. Okay, so what's going on here? So we're taking that number in here and then putting it in here. Let's see what's coming out of here. So let's print this to the console. And the great thing about Python is it will run the script up to the point where the error is happening. So we should get the output even though it's failing down here. There we go. So we are getting two values, 701. Well, you probably already noticed what I did wrong, or maybe you didn't. Obviously, I was a bit of an idiot. So I was reading these values from basically nowhere. I forgot to tell it that we look at the object for these settings. So we put our user data on the cube and I forgot to tell it. So let's add this to all of these. I leave all these errors in because I think this kind of stuff can happen to anyone. And it's always good to see how you do the troubleshooting, and even when it's such an obvious error, it's probably better to see how I fix it than to just gloss over it. Alright, so we don't need this anymore, I hope. Compile it, execute it, and now it works. So, sorry for that. Let's see what's happening. Now this is moving around quite nicely. Let's give it a few more frames. And if we play around with these sliders, we can change the speed and distance of our movement. And we could, of course, even animate it. So I'll just go here and change it to this. And there you go. Very nice. Now we're not using the random function yet, so we're going to do that now. Let me just get rid of this again. So now to use the random function, you have to import the random module, which is part of Python, not Cinema. So it's called import random. And from there we get a random number. So the easiest way to get a random number is just to type, let's call our random number random, and it's random.random. And this is going to give us a random number between 0 and 1. It's going to be a floating point. Now this is going to give us a really almost random number, at least a unpredictably random number, because we haven't set the seed. We have read the seed, our preset, but we haven't actually set it yet. So the random function will just pick a random number based on the current time, for example, and use that as its seed, so we get a different number every time we run it. But we want a fixed random number, if that makes sense. So let's set the seed before we call the random function. Again, that's really simple. It's just called random seed. Oops, come on. And we just feed it our random seed. That's all. Now this is setting the random number generator to a specific list of random numbers, and here we get them. Okay, now let's use that random number, and we are going to use it. Actually, let's use it with every single, with all of these. So we've got the rotation, and we are also using the sine and cosine down here for the position, so we could just as well use it here. So now it's going to be equally used for rotation and for position. Let's see what happens. And again there's an error. And again there's our problem with the float. So let's make this a float. Oops. Oh, right. Again, my mistake. The problem we see here is that sine and cosine, they don't return a single number that we can multiply. They return a list, and we can't multiply the list with that floating point number. What we can do, however, is we can take this out, and I can take this out, and we can just multiply the radians directly. So this should work now. Yes. Let's clear the error messages, and let's see what happens. Let's make this a bit slower so we can see what's happening. Okay, so there's some randomness in this movement now, and you see when I change the number, this changes as well, without me touching any of the other values. And of course what we can do now is we can just make a whole bunch of these. And now, because they all have the same seed, because I copied them, they should all be at the very same position. And they are. But if I go ahead and change these, okay, so let's see what happens. Now we get some interesting, oh well, not super interesting, but at least a somewhat interesting random movement here. Now this one here is a bit slow. Let's change it. Let's give them all slightly different values. And make them a bit smaller because we want to see what's going on. And there you go. Now you can probably imagine if I were to create 100 of those, you can get some interesting organic movement there. Okay, I think this should be all for this week. I will send you this source code with some nice comments and everything in there, so it should be relatively easy to understand, I hope. And you can then play around with it. I'm really looking forward to see what you're coming up with. If you have any questions, just shoot them at me in the forum, and I'm really happy for any kind of feedback. Just let me know if you want to hear more about anything in specific, or if you had any problems with the way I presented it, just let me know, and I will try to fix it. Until then, I hope you have fun with cinema and with FX PhD, and see you next week. Bye!